Hello, geometry students. I hope you are having a fantastic day. We are continuing on in chapter 4. This entire chapter is about what we call transformations, where we are moving points or triangles or quadrilaterals in the coordinate plane. So our first lesson, our first type of transformation was on translations, which is when we slide a figure. Our second lesson was on reflections, which is where we flip a figure. This lesson is going to be on rotations, and that's a pretty common word, which we're basically just spinning a figure. Typically, unless stated otherwise, when we rotate in a counterclockwise direction. So just like with the last two lessons, we're going to be talking in Zoom about how to find a picture in real life that represents rotation. And the notes are going to be more about the mathematical aspect of rotations. Now, if we were teaching this in person, I would do a lesson with you on learning to rotate a figure using a compass and a protractor. But it is a very hands-on activity, and I don't think it really lends itself very well to videos. So what I'm going to be doing for this lesson is just teaching you how to do rotations in a more algebraic method where we can actually add or subtract or change signs from the numbers of our coordinates of our points. So this hopefully should be fairly straightforward for you. It does take a little bit of time to do. If you have graph paper, that helps. It's not necessary, but it does help. So we're going to do 3 examples of 3 different kinds of rotations. The first example, example 1, is going to be on a 90-degree rotation. 90-degree rotation. So we're going to take 3 points, rotate all 3 of them 90 degrees about the origin, and then we're going to end up with a new figure, which we call our image, that occurs after the transformation. So let's go ahead and use the points U, V, and W. For this method, we're basically going to do a chart of our points here. So U is at the point 0, 0, V is at the point 5, 2, and W is at the point -1, 6. So make sure that you have those written down. Now, rather than getting out a ruler, compass, and a protractor and trying to figure out where U prime, V prime, and W prime are, I'm basically going to tell you a recipe or a code for figuring them out by adding and subtracting and changing signs or whatever. And actually, it's not really adding or subtracting, it's changing signs or changing positions would be more of the correct way of saying it. So when we do a 90-degree rotation, we're going to write the recipe down as saying that every X and Y needs to be transformed so that we take the opposite of Y and put it first, and we take whatever X was and put that second. So for our first point, 0, 0, it's not going to change at all because since the 2 numbers are the same, when we switch them, we can't tell. And 0 is the only number that does not have a sign, so it does not have an opposite. But let's take a look at V, +5, +2. Can anybody guess, based on the recipe that I have here, where V prime would be? Where do you think V prime is if this is my recipe that I just talked about? We want to switch the order, so we're going to put the 2 first and the 5 second, but we need to change the sign of what was our Y. So instead of being +2, we're going to write -2, 5. -2, 5 for V prime. Now I want you to try to do W prime. If we switch the order but change the sign of the Y, we're going to have -6 first and then -1. Let's go ahead and graph that and get a visual of what that looks like. If my U is at 0, 0, and my U prime is as well, I can write U prime right next to that. We can see that when we're rotating a figure about the origin, if one of the points is on the origin, that point does not move. All right, let's graph V. V is at 5, 2. And when I rotate it, it goes to -2, 5. So I'm going to put a new point there with V prime. Now, if I had used a a compass and protractor, I would be drawing a dotted line from my pre-image point to the origin and then measuring a 90-degree angle here. So hopefully if you zoom in, you can see how that's exactly 90 degrees. You can do that by measuring, but I do think it's easier if you have the recipe. All that we had to do is switch the order of the numbers, but change the sign of the y. So that's how we got -2, 5. I'm going to erase this measurement here, but I just wanted you to see that we could have done this using a compass and a protractor, and it would have shown us rotating that pre-image point exactly 90 degrees about the origin. Okay, now I want to do my third point. W prime is going to be at 1, 2, 3, 4, 5, 6, -6, -1, and I'm going to go ahead and put a W prime here. Now, just like with my other transformations, my points should not have changed. Let's graph the original triangle here. We're going to go from 0, 0 to 5, 2, and then W was at -1, 6. So let's get that on there. 1, 2, 3, 4, 5, 6. My W is right here. Have to move this over. 2, 3, 4, 5, 6. Okay, there. So my original triangle is right here. I got so caught up in showing you that rotation, I don't think I ever put W on there. Some of you are going, where was W? It wasn't there yet. That's all right. Let's just put a W here and a -1, 6. All right, and now let's go ahead and trace our image from U prime to V prime to W prime and then back again. Notice that my image is the same size as my pre-image, but the whole thing has been rotated 90 degrees counterclockwise. So that's how we do a 90-degree rotation using the recipe up above. Now we're just going to do 2 more examples here. And again, you are getting points for taking these notes because this is going to be the only time that you see more of the mathematical aspect of the rotation versus the real life representation of the rotation. So let's do example 2. For example 2, I want to use the points C, D, and E. And this is going to be a 180-degree rotation. 180-degree rotation, and we're going to have a recipe for that as well. With a 180-degree rotation, we want to take our X and our Y. Now this one I think is easier. We don't need to change the order at all. We just change the sign of both. So go ahead and make sure you have that written. XY gets transformed into -X, -Y. So we'll do that with all 3 of our points. C is going to be at -1, -3. D is at 4, 2. And E is at -5, -1. And then we're going to write C prime, D prime, and E prime for where our image points are. Now again, we're not changing the order this time, we're just changing the sign. So what do you think -1, +3 would become? What would -1, +3 become using this recipe? If we keep the order the same but change the signs, it would become +1, -3. +1, -3. All right, now D prime would become -4, -2, and E prime would become +5, +1. All we're doing is changing the sign of the numbers. Let's go ahead and get a visual of that by graphing. If I start out with C at -1, 3, I'm going to put a dot there. And please, 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 feel free to pause this video anytime you need to. This is not a race. You can watch it as many times as you would like. So C is at -1, 3, and C prime is going to be at +1, -3. Notice again, if I had done this with a compass and protractor, I would have been drawing a dotted line to the origin and then showing 180 degree movement here. So I can do that by measuring, like I said, but that's just a lot more time consuming than actually just changing the signs on your numbers and graphing your points. So let's just finish doing C, D, and E before we go too much further. So C is at -1, 3. D is at 4, 2. And E is at -5, -1. So if we do this, we can get an idea. It's kind of a skinny triangle here. An idea of our original triangle. That would be triangle CDE, our pre-image. Now I just did C prime a minute ago. That was at 1, -3. And I think I'll put that in purple again like I've been doing before. And then D prime is going to be at -4, -2. So that will be right here. D prime, -4, -2. And then E prime will be at 5, 1. 1, 2, 3, 4, 5, 1. E prime, 5, 1. All right, let's join these points. Notice again, the size of my figure has not changed. I have just rotated it 180 degrees. So I have just changed the sign, rotated this 180 degrees around the origin by changing the signs of my X and my Y. Okay, the last one that I want to help you with is a 270 degree rotation. So 270 degree rotation. Now we've talked about 90 degrees quite a bit so far in class, and we've also talked about 180 degrees. We all know that 90 degrees is a right angle and 180 degrees is a line. Does anybody know what you get when you go 270 degrees? How much of the way around a circle is that? 270 would be 180 plus 90 more, so 3/4 of the way around a circle. So it is our the most degrees that we've rotated so far, and this will be our last example. So example number 3, for a 270 degree rotation, the recipe that we want to use is with X and Y. This one's kind of interesting. We switched the order, but this time, instead of changing the sign of the Y, we change the sign of the X. So XY becomes Y, -X. So again, two things are happening. We're changing the order, and we're also changing the sign of the X. Let's go ahead and give 3 points, H, I, and J. H is at -3, -1. I is at 2, 4. And J is at -1, -5. And I want to figure out what H prime, I prime, and J prime are. Try to do the first one if you can. If H is -3, -1, and I have to switch the order and change the sign of the X, what would my next point be? It should be at -1, 3. I prime will end up being at 4, -2. And J prime will end up being at -5, 1. Okay, so let's go ahead and graph those. This will be our last example. Again, you're getting 5 points for showing that you have all 3 images graphed. Okay, so H is at -3, -1. I is at 2, 4. And J is at -1, -5. So I'm going to connect those dots to draw my triangle. And I think I will just go ahead and put the H, the I, and the J on there. And then if I want to graph my 3 image points, H prime, I'll graph at -1, 3. I prime will be at 4, -2. And J prime will be at -5, 1. So again, same size triangle, but just rotated a full 270 degrees about the origin. Okay, so this is the math part of rotations, and then we're going to be doing the real world part of rotations in our Zoom session. Thanks for listening, you guys. Talk to you soon.